Okay. Modules. Oh, modules. Modules was one of the areas that I really struggled with early in my Rust career. Figuring out where to put the files and what the file name they should have, and how to do the use statements versus the mod statements. And all right, so this says to do fix the compiler error about calling a private function. Don't let anybody outside the module see this. So I think all they're looking for is the fact that we need to be able to call make sausage from here, which means this needs to be public. Yeah. So that's pretty straightforward. I think you can also put pub super in here and it'll still work, and pub crate. Yeah, all of those work. But I think that just adding pub would be fine. What's next? Modules 2. Delicious snacks. Okay, to do, add the following 2 use statements after fixing them. This is saying up here you can bring module paths into scopes and provide new names for them with the use and as keyword. All right. So we're looking for a fruit and a veggie. We already have a fruits and a veggies. So I think what we're looking for here is we want to use self fruits pair as fruit. And that way this will map to this, right? So it should print out favorite snacks, pear, and cucumber. Okay. Oh. Private constant import. Do I have to say pub use? Yeah. To export them. They have to be pub use. Okay. Modules 3, yes. You can use the use keyword to bring module paths from modules from anywhere, especially from the standard library, into your scope. To do, bring system time and units epoch from the standard time module into your scope. Bonus style points if you can do it with one line. Well, I can definitely do it with one line. Yeah, so I can use the code action in my editor to say import Unix epoch and then system time. And it should put them together in one line. And it does. So I get bonus points. There you go. Next, Hashmaps. Ooh, Hashmaps. A basket of fruits in the form of a hash map needs to be defined. The key represents the name of the fruit and the value represents how many of that particular fruit is in the basket. You have to put at least 3 different types of fruits, apple, banana, mango, in the basket, and the total count of all the fruits should be at least 5. Okay. To do, declare the hash map. Okay. That's easy enough. 2 bananas are already given for you. To do, put more fruits in your basket. All right. So we need 3 different types of fruits, and they have to total at least 5. Okay. Basket, insert, string from. Or we could use the into, right? Apple, into, 10. There's 10, and basket. Insert. We already have banana and apples, so we'll add mango into 17. Lots of mangoes. There we go. So I think this is just teaching us how to define a hash map and then how to insert things into it. And I can use the into here because it's already been defined as being a string up here. Scoop says that's a big basket or really tiny fruit. Reggie says, stopped 3 modules. Guess I never tried again afterwards. Well, that's one of the reasons I'm going through this, is to talk my way through it explaining my reasoning as I'm doing it, and then hopefully being able to chop these up and put them up on YouTube and help other people through them. I believe other people have done that as well, and there's probably blog posts about this as well. Graph says more like it's been defined in the string of the functions. Oh, yes, you're right. Here it's defined as a string, and we're returning it. So therefore, Rust also knows it has to be a string U32. You're right. If it didn't, though, I would have thought that the first insert would have defined the type as well. Right? If I create a new hash map, let my map equals hash map new, and say my map insert string from foo 12, right? And I save that. Oh, it didn't complain that it's not used. Okay. And it implicitly defines it as string I32 just by that, even though I'm not returning it. So I should now be able to say bar into. Yeah. So it works both ways. So the type inference machine can handle it from the return type or from the first insert type or whatever. So it's all good. It's all good. What's next after Hashmaps 1? Unsurprisingly, it's Hashmaps 2. Scoop says, but you can't use into on both lines in the second example. Right, because it wouldn't be able to figure out what the into is into. I agree. Hashmaps 2. We're collecting different fruits to bake a delicious fruitcake. For this, we'll have a basket, which will represent in the form of a hash map. Okay. The key represents the name of each fruit we collect, and the value represents how many of that particular fruit we have collected. 3 types of fruits, apple, mango, and lychee, are already in the basket hash map. You must add a fruit to the basket so that there are at least one of each kind and more than 11 in total. We have a lot of mouths to feed. You're not allowed to insert any more of these fruits. Okay. So we have the fruit, apple, banana, mango, lychee, and pineapple. We have apple, banana, mango, lychee, and pineapple here. We have a fruit for fruit and fruit kinds. For each one of these fruit, insert new fruits if they are not already present in the basket. Note that you're not allowed to put any type of fruit that's already present. Ah, okay. I wonder if they're trying to talk about the entry API here. Right? Because we're added apple, mango, and lychee. So we're going to be trying to add a banana and a pineapple. And they said, what, they have to be at least 11? More than 11 in total. All right. Well, we already have 11 here, right? 4 plus 2 is 6, plus 5 is 11. So any that we add are going to be more than 11. So what we can do is use the entry API. We can say if let, I'm forgetting it, entry vacant v equals basket entry of fruit. Do something. Standard collections hash map entry. Scoop says entry works contains too. Oh yeah, we could do if basket contains. Right. Maybe we'll do it both ways, and then we that way we could show how each one works. Expected fruit found fruit. Like this. There. Okay, so now we can just say v dot insert. And I don't know which fruit it is, but we'll just add 7 of them. Whatever fruit it is. There we go. So that solved it using the entry API. We can also do it using the contains, as Scoops points out. We can say if not basket contains fruit And again, I don't know if we need the ampersand there. And we can say basket insert fruit 7. And now it's saying we don't need the entry. Oh, it contains key. Yeah, and that passes. Oh yeah, this, of course. And this is another way to do it. Basket entry fruit or insert 7. Even better. Why didn't I think of that? And now we don't need the entry. Let's clean that up. Remove all unused imports. There we go. Okay, that's much better. And Mugafa, you beat me to it. You beat me to it. I needed Clippy to tell me about, to remind me about the entry or insert. All right, very good. That was Hashmaps 2. Hashmaps 3 is next. A list of scores, 1 per line of a soccer match, is given. I don't know. I don't like the use of this passive voice here. Each line is of the form team 1 name, comma, team 2 name, comma, team 1 goals, comma, team 2 goals. This is almost like an advent of code problem, right? Example, England, comma, France, comma, 4, comma, 2. England scored 4 goals, France 2. You have to build scores, a scores table containing the name of the team, the total number of goals the team scored, and the total number of goals the team conceded. Okay. So we're going to look at, and we're going to return these scores for each one. So I think we can do entry again, because we want to look up or create a new one, a new score, right? A new struct team. If it's aren't already in there, we have to insert it. And if it does, so we can do this, right? We can say let team 1 is equal to scores dot entry, and this gets them or insert of no, right? So team 1 name or insert team goals scored. Oh, team default. Sorry, I missed the fact that default was up here. All right, and this should be a mutable reference to a team. And now we can say team 1 dot goals scored is equal to plus equals team 1 score, and team 1 goals conceded is equal to plus equal team 2 score. And then we can do the same thing for team 2, right? Except these got reversed as well. And this gets changed to team 2. Yeah, I think that'll work. Let's find out. Ta-da! That worked. That's pretty straightforward. Yeah, I was thinking, so this is using the entry API, kinda, right? Because this is team 1 is a direct look into the value of the hash map for team 1 name. The other way to do it would be to have a match statement on it and have the entry vacant or entry occupied. And if it's vacant, then we set it to team 1 score and team 2 score. And if it's occupied, we do the addition. But this, I think, is the simplest way to do it. All right, good. We're up to the second quiz out of 3 quizzes.